En, dva. Vrata, prosim, če lahko zaprete.
Unfortunately, we don't have sound in the booth. Sorry.
Dragi poslušalci,
apologies, we don't have sound in the booth.
In vabljeni na tretjo sekcijo
Unfortunately,
18. kolokvija.
we are still waiting for the connection.
Upam, da bo današnja sekcija vsaj toliko zanimiva kot včerajšnja podelitev nagrad. Tako da predlagam, da pričnemo. Imamo 3 predavatelje, 3 teme in na podij vabim prvega, dr. Marjana Tušarja z Kemijskega inštituta, ki je skupaj z ekipo dr. Lidijo Ržek ter magistrom Mojco Ravnikar Turk pripravil zanimivo temo, in sicer grafični prikaz zahtev za volumenske lastnosti asfaltnih zmesi. Dr. Tušar, prosim.
Ja, predsedujoči, hvala lepa. Predstavitev samo ob drogo pa ne bom plesal.
Still no sound in the booth, sorry.
Gospe, gospode, kakor je ponovem tudi tisti vmes, hvala, da ste tukaj. To se pravi, kot je že povedal predsedujoči, sem z sodelavkama pripravil tole predstavitev. Moj motiv za to predstavitev je bilo v bistvu to, da se velikrat, ko se pogovarjamo o asfaltu, pogovarjamo velikrat, mešamo jabolke pa hruške, po domač povedano. Eden govori o volumskih, eden govori o masnih procentih. In tukaj je moje mnenje, in tudi mislim, da je to pravilno, vedno, kadar gledamo na asfalte, moramo gledati volumsko. Ker tisto, kar imamo konkretno v plasti, je volumsko, tisto ni masno. Naprej gre. No, vsebina mojega predavanja je, najprej bom nekaj povedal o slovenskih zahtevah za proizvedene asfaltne zmesi in vgrajene asfaltne plasti, potem bom nekaj povedal o volumski osebnosti bitumna.
Also, what I've noticed is that you can introduce volume curves, recipes for asphalt mixtures. I will begin with triangular presentation of requirements for volume properties, triangular presentation of recipe composition, and then where we can move on. So, looking at the requirements, Slovenian requirements, for the majority of mixtures that were listed here, AC surf, AC base, and with bitumen mastics, we have the content of the cavities in the mixture. With SMA, the minimum content of bitumen is required. Then the requirement to fill the air pockets with bitumen and the content of cavities in certain layer. Only in bitumen you have mass percent. Elsewhere we are discussing volumes. And here I have another comment. Recently, I've noticed that 5 to 7 is the requirement for cavities within AC base. This is absolutely in light of knowing the method. In method, it's 1-to-1 repetitiveness. If we make an asphalt mixture with 6% of cavities, with the next test we have 7.1 and we are out. So these requirements are too narrow. Moving on, last year we've discussed for AC base to set the requirement for 3.8% of bitumen. And we discussed would it impact our requirements, and I will try to answer this with my presentation. First issue, volume content of bitumen in European standard 13,108 says the use of this standard is mandatory, so the content of bitumen that we have or present needs to be corrected when we look at the minimum share of bitumen. This is a simple equation where we see thickness of standard aggregate 2.650, which is the thickness of the limestone, and we have to correct it so that we can compare it with our requirements for the bitumen content. I prepared a small table where we checked the content. To correct the content, the requirement for SMA is 6.3. If we put 6.3 to SMA, which is a stone aggregate, a limestone aggregate, we get 6.4 with limestone. In basalt, we get to 6.9. And if we add steelwork slag with 3.4 thickness, with 6.3 bitumen, we get 8.1. This is a huge excess. To fulfill the requirement 6.3, it would be enough to add limestone aggregate 6.2 bitumen, in basalt 5.8, and in steel slag 6.9. This is to fulfill the minimum condition, but we have to be aware that durability of asphalt mixtures is higher with higher content of bitumen. So to steelwork slag, we add much more than 4.9. And we have asphalts based on steelwork slag with 6% of bitumen are much more durable. So here, let me talk about minimum requirement. And not that we should go lower with the bitumen content, but once we discuss whether we fulfill the minimum criteria, we have to consider the values. Then I had a look, if we look at in volume term at the sieving curves, if we have the mixture of fractions in basalt and limestone, this volume assessment takes part only in mixtures. If we have limestone and other fractions from slag, we get an interesting question. The mass curve goes nicely through the center, but in volumes at the sieve 2, we are over the requirements. So in this case, with huge differences in the thickness of the aggregates, the sieving curves should be considered not in mass, but in volume. It is an easy, simple calculation, so it should not present any problems. Moving on to the recipes, in Slovenia, we are using Marshall method. We set the sieving curve, we have the testing samples, test the volume properties, and we choose again, no sound, sorry, no sound in the booth.
Oh, it's back.
And now we have replaced it again, but so far in volume terms, you can see how the volume assessment of the asphalt mixture should look like. On top, we have the content of stone aggregate. Here, we have 100% of air. Here, 100% content of bitumen. And in the center, it's a third of each component. Higher we go, more stone aggregate we have. To the bottom right, we have air and bitumen. Where can we move? What is the minimum share of stone aggregate? These are the cannonballs, nicely placed. And we have 65% of space filled with stone aggregate. This is minimum that we can use the stone aggregate if these the grains are round with different shape, we can go under 65. And the maximum level in the database, I've checked and saw that in the database 400, the maximum share of stone aggregate is up to 90%, but truly you can put more. More you get fine particles, even finer filler, you can fill it up to 100. But from the real database, I got the data 90%. And let's begin with air cavities now. This is this point in the center. This is the volume presentation where we have one specific mixture, AC base. This is this point. And then I set the limits for the air pockets in the layer. First is slightly wider. It's nicely presented on the chart, and the requirement for air cavities in testing samples for AC base are quite slightly unrealistic. And where our asphalt mixture can set into this green area. If we consider the air cavity content, then the filling in, we had minimum requirement, 50%. Then we had the maximum requirement, and it's 68%, if I remember it correctly. So you can compare it in this graph. And our asphalt mixture, the area has reduced to this green surface. And this specific asphalt mixture here quite on the edge of the requirements. Moving on, requirement for the content of bitumen, things get complicated here. They are set in mass percentages, and here we have to make a supposition that we have a limestone aggregate with 2.7 thickness, and the final thickness is 1.8 to be able to make the chart, the calculation. So anyhow, this is what we get. With this requirement for minimum content of bitumen, we additionally reduce the area where we can set the recipe. Coming closer with additional requirement for 3.8% of bitumen, the area of allowed area for the recipe has been reduced significantly. This new requirement truly cut our range, and we might have better recipes. The recipe for AC base scope is relatively small. And checking a real mixture that was made following the Marshall recipe process, and the recipe was set in those according to the requirements that are implemented now. It got at the top layer 0.4 was the requirement for bitumen, and we got at the end as the optimum level 4% of bitumen, which is within the range, but we've tested it at the upper edge of the allowed range. And then you wonder, why don't we use the whole space below? If we had free hands, we could set the experiments like this. Let's cover the space in volume and have experiments. It's called planning the experiments. This is the process, and this is the full factor plan. To follow this plan, we can cover all these points with relevant recipes. Here we have 7 different recipes, possible recipes, and in between these points we can make an interpolation for the optimum recipe, and we would cover the whole area. Second thing that we can additionally do, we can say and add additional factor, introducing filler as the additional factor. We get additional dimension, 4 dimensions, and with stone aggregate we add the additional dimension, and it is an independent component that would allow us to design asphalt recipes, and we can also consider the fraction 0.2, and we get dimensions that can no longer be graphically illustrated, but it can be done with more than 4 dimensions, the note, with the method of main axis method. This is what we've done in the doctor thesis. The conclusions are 3 basic components of asphalt mixtures are stone aggregates, air pockets or air cavities, and the content of bitumen. And they are most credibly presented with triangular presentation. And the main goal of the study was to illustrate the usefulness of graphic illustrations of volume properties to plan the asphalt mixtures. And what we have in the standard requirements, we can illustrate that in graphic presentation, and we visually can see where our recipe is placed in graphical illustration. And we realize that this type of graphic illustration can also be used for optimization of recipes, and can adequately help us set different recipes for the properties, for the components who are less volume dependent. Lower noise asphalts depend hugely on the volume composition of mixture of air cavities and bitumens. In some cases, these presentations could be expanded to 4 or more dimensions, and we always have to consider the volume percentage of the components. The basis for our article for this presentation was the article that we have prepared for the Construction and Building Material Journal, and I took 5 to 7 lines for air pockets or air cavities criterion. So all the images presented are published in the article. For the conclusion, let me take my daughter, Kaya Tušar, helped us with graphical presentation. Older people need younger forces, and she used Python and just draw all the triangles, and she helped us truly a lot to make this presentation. And thank the Public Research Agency for the support. Thank you very much.
Let me thank Dr. Tušar for this paper presentation. I suggest we provide questions and make comments at the end of all presentations. Next speaker is Mrs. Nika Matul from the Faculty of Civil Engineering and Geodesy. She's been active in the field of design, control, and the preparation of professional studies. She is also a member of the Asphalt 4.0 committee within the Slovenian Asphalt Payment Association. Good morning. I will present today a kind of report on the meetings of the Asphalt 4.0 committee The title is Energy Consumption in Asphalt Plants, Emission and Cost Reduction. In the professional committee, Asphalt 4.0, we, among other things, also discussed the issue of energy consumption and emission generation in asphalt plants. This is a very pressing issue due to the runaway energy prices. There is no end in sight. Therefore, we decided to tackle this topic within the committee. I would like to thank all the colleagues from asphalt plants in Slovenia who actively engaged in the discussion, data collection, and its analysis. Because there is a strong initiative to reduce emissions and to transit into circular economy, we will have to introduce green measures that we have often touched upon these 3 days. We'll have to employ all international tools and findings in order to decrease emissions. Of course, the characteristic of asphalt industry is high energy consumption, reflecting also in huge CO2 emissions. An average asphalt plant produces from 15 to 20 kilos of CO2 with the production of 1 ton of asphalt mixture. This does not involve the transport of materials and the construction of the mixture. In the production of asphalt mixtures, most energy, 90%, is used in the heating of the aggregate. Then the temperature needed for the efficiency of the plant. We use dry aggregates. This is one measure. We can reduce the heating temperature of the aggregate. And, of course, we can improve the efficiency of the plant itself. The experience from practice in our plants and also the data in literature shows that the reduction of moisture in the aggregate is the decisive factor. Granulate has to be protected from humidity and moisture, because most energy is used to evaporate this moisture. And this could lead to a 10% decrease in energy consumption. And then the heating of the aggregate to 170 degrees Celsius. We often discuss aggregate heating, but nobody mentions the temperature that needs to be reached. For example, we can compare heating aggregate to 200 compared to 170 degrees Celsius, 100,000 tons of asphalt mixture per year, and we could save 70,000 liters of fuel oil annually. This accounts to 70,000 euro. And this means 1.4% of the revenue of the plant. The reduction of temperature of the asphalt mixture by 10 kelvins results in 3% energy. The possibility to lower the temperature of heating asphalt mixture has to be discussed separately, case by case, and the decision on the final temperature of the mixture should be adopted by those in charge of the plant, because they have to meet the requirements of the customer. As we all know, the alternative option to reduce the temperature is also the production of warm asphalt mixtures with special production procedures, and by adding additives to reduce the temperature of asphalt mixture, we can produce warm asphalt mixtures. The technology of construction does not differ. And as we have already heard at this colloquium, it is mainly about the improving the working conditions for workers, less aerosol, and we avoid the possibility of overheating bitumen. There are a number of other factors impacting the energy losses. The use of energy for heating the reservoir for bitumen, the energy used for the operation of various machines. So in the asphalt plant, there is usually 100, on the average, 100 various machines. But the equipment in our plants is quite old and sometimes obsolete. With the introduction of new energy-efficient machines, we could save 10% of energy, meaning that the energy efficiency can be the result of the investment in insulation and using more favorable periods of energy prices. The staff members have to be made aware of the importance of energy and the impact the energy prices have on the performance of the plant, and what can we expect to be efficient in fighting climate change. We need to take measures, of course. Of course, the European Council adopted the deal we are familiar with. What does it mean for our industry? It means additional duties and fees for energy users. But the asphalt industry has developed new concepts, new technologies, game-changing technologies, and we have to make progress in this direction in order to decrease emissions. The calculation of all emissions in asphalt industry is very complex. We need to take into account all phases in the entire process, from the acquisition of raw materials, production, transport, construction, and use, taking into account the lifespan of the product, being the asphalt pavement, and also recycling and reuse. Most emissions are generated during the production phase, but also in all other phases. We should not neglect this fact. In this industry, we can contribute in various ways. One of them is the recycling. That is very important because it's the construction material, the only construction material that can be 100% reused, and it can be applied in asphalt mixtures of best quality. The savings can be connected with the aggregate, and we can also lower emissions during the transport. This is not all. This has a favorable impact on the production of emissions. I'm talking about recycling. And also the cost dimension is to be stressed. New technologies of the production of asphalt mixtures enable the use of 90% of asphalt aggregate in new asphalt mixtures, maintaining high standards of quality. The importance of reducing the temperature in the production of asphalt mixture. This is closely associated with the lower emission production. This has been mentioned already. With lower temperatures, the production of emissions drops. This graph also shows additional consumption of energy necessary for the production of asphalt mixtures, depending on the moisture content in the aggregate. Higher moisture level means higher energy consumption and higher CO2 emission generation. The CO2 emission production depends also on the use of the energy source used by the asphalt plant. Natural gas compared to the use of extra light fuel oil or liquefied gas. If we replace fuel oil with natural gas, we can reduce CO2 emissions by 24%. With all the measures mentioned, we need to underline the good organization of work and logistics from the site of production to the location of construction. This wasn't stressed in the past, but now we are aware of its importance. We can save or lose energy. Optimization of the entire process in the asphalt industry ensures the appropriate quality of payment, and this quality is impacted by all phases, from the planning, design, production, transport, construction, and quality control. Quality implementation and the construction can prolong the lifespan of the asphalt pavement. Each additional year in the lifespan can result in 20% savings of emissions. Now the analysis of energy consumption in Slovene asphalt plants. In the professional committee Asphalt 4.0, we collected data on annual production of asphalt mixtures, annual energy consumption for 2018, 19, and 20. And we took into account 5 plants from 50 to 100,000 tons of production per year. They provided us with the energy consumption data, and based on these data, we calculated the average energy consumption for a production of 1 ton of asphalt mixture, ranging from 60 to 100 kilowatt hours per ton. The calculation of the average consumption of the best and the worst performing plant results in a difference amounting to 40%. We established in the committee that in Slovenia, in the field of energy optimization of asphalt plant, there is still a lot to do. Maybe another aspect regarding the data obtained the situation on the energy market. This is the graph illustrating the electricity prices. And we can also follow the energy price, the electricity price trends in previous years. Now the prices of natural gas on the stock exchange. These are the most recent months and the prices. And my question for the discussion is, and also to conclude, does it pay to introduce measures to reduce production, the energy consumption in production in asphalt plants? Of course, my answer is yes. This is an opportunity for our industry to present itself as more green industry, as greener industry. The introduction of new concepts and technologies in the asphalt industry supports better conditions for more sustainable, safer, and more comfortable asphalt surfaces with lower carbon footprint. Thank you very much for your attention.
Thank you, Nika. I believe that in light of the present situation on the energy market, energy prices, we will all turn to Nika after the third section with our question. Let us continue with our lectures. I invite technical team. And let me announce Dr. Thorsten Butz. He will present his paper online. Dr. Butz has finished the chemical studies at the faculty in Germany. He is the scientist at the German Scientific Institute Petroleum, and since 2000 head of analytics for the development of additives in Hamburg. Please, technical team, to play.
Ladies and gentlemen, I would like to start my presentation with a question. Is war mix asphalt taking off now in Europe? And I try to answer this at the end. After an introduction, I will give a short overview of war mix asphalt technologies and the global use. I will explain 2 examples of asphalt projects with war mix, and finally my summary and conclusions. The growing awareness of global warming and the adverse consequences triggered a lot of actions in the world now. The industry, politicians, and authorities shift their strategies to more sustainability. The European Green Deal contains the aspiration of a climate-neutral Europe in the year 2050. Several other states and leading companies announced similar intentions to reach net zero greenhouse gas emissions in a similar time frame. Also, SASOL announced the ambition of net zero until 2050, and this includes the transformation of the Fischer-Tropsch process to utilize renewable electricity, green hydrogen, and renewable carbon sources, the so-called SASOL EQFT initiative. What can the asphalt sector do to contribute to improve sustainability? Some life cycle analysis indicated 2 strong levers: high reuse and recycling rates of used pavements, and extended service life by constructing perpetual pavements with durable lower asphalt layers and then just occasionally substitution of the thin bearing course. Moreover, dry storage of aggregate and reclaimed asphalt can help to reduce the fuel consumption in mixing plants. Also, the switch from high carbon footprint fuels to less carbon footprint fuels is also helpful. For example, use natural gas instead of coal, or even wood pellets. The use of bio-oils and lignin as bitumen extenders or replacements in future could also help. And of course, the use of warm mix and cold mix asphalt. The warm mix asphalt technologies can be classified in 3 groups. Group 1 are the organic additives. These are mostly waxes. These additives decrease the binder viscosity above the melting temperatures. They may stiffen the binder, and this has to be taken into account for the asphalt mix design. The addition takes place in the optimum case pre-blended with a binder, but also hot liquid or solid addition directly into the asphalt mixer is possible. If solid addition takes place, an extended mixing time is required to get optimum homogenization. The second group are the chemical additives. These are mostly surfactants. Chemical additives reduce the friction between aggregates and binder and thereby allow temperature reduction. The binder properties remain largely unchanged and even may improve the adhesion to the aggregates. The addition is generally in liquid form, but measures for safe and compliant storage and use is required because these additives are often classified as irritant and water polluting. The third class are the water-based technologies. This is either direct bitumen foaming with water or the in situ foaming by using water-emitting minerals such as zeolites. These technologies increase the volume and reduce the viscosity of the bitumen for a limited duration. The binder properties are unchanged, but there is a risk of residual moisture in the asphalt mix, which might result in poor asphalt quality. Investments for a foaming unit are acquired or for a zeolite powder storage and dosage system. All these technologies improve the ability to produce and pave asphalt at 20 to 30 degrees lower temperatures. The usage is globally with different regional preferences. The leading country in Europe is Norway, with more than 22% of the total asphalt mix production. Also in France, a lot of warm mix asphalt is already produced. For comparison, in the United States, about 90% of the total production is warm mix asphalt, and all these numbers are from 2019. The diagrams below show the total tonnage in Europe, and on the right-hand side, the percentage of the total asphalt production. While the cold mix asphalt amount is staying constant over the years, we see a significant increase of warm mix over the years. How is the situation in Germany and Slovenia? In Germany, warm mix best practices guidelines were published and updated this year. In addition, specifications for low viscous wax modified bitumen and polymer bitumen were published. Such binders are used for process reliability, for example, paving at cold weather or paving stiff mixes, and they are also used in co-modified high-performance binders. But to be honest, besides mandatory temperature reduction for tunnel paving and mastic asphalt, almost no warm mix asphalt took place in Germany up to now. And the reasons are they were simply not requested by the authorities, and they were in the normal price-driven tendering process not competitive because of higher cost. But now in Germany, warm mix asphalt gains importance because of an extremely low bitumen fumes and aerosols limit will come in force beginning of 2025. Ongoing test pavements have shown that probably warm mix asphalt in combination with exhaust systems at the pavers have to be used to obtain values as low as requested, and possibly additional organizational measures for the paving crews will be required. The photo at the right-hand side is showing such an exhaust system at the screed of a paver. On the left-hand side, we can see the chimney of this exhaust system. What about Slovenia? Since spring of this year, with the publication of a technical specification for warm mix asphalt, Slovenia belongs to the few countries which have a regulation for warm mix asphalt. Now let's have a look at two examples of warm mix projects. For the first, I'd selected one of Slovenia. This was the first warm mix asphalt trial in Slovenia back in the year 25. It was at the road between Ljubljana and the airport. And the busy diagram is showing that 2 layers were paved using bitumen 5070, and in the warm mix section, 3% of the organic additive Sazobit were used. The reference section, hot mix, was without additive. The table contains a lot of results. I do not want to go into detail, just to point at a few important topics. The temperature of the warm mix section was between 20 and 25 degrees lower compared to the reference, and this resulted between 12 to 20% less heating fuel consumption and up to 46% less fumes emissions. The compaction and the air voids were equivalent for both sections. My second example is from a research project at the Technical University of Prague, which contained also paving a test section in central Bohemia in November of 2016. In this case, the organic additive Sazobit Redux was used, which is specifically designed for warm mix asphalt. The action principle can easily be explained with this viscosity over temperature diagram. The light blue curve shows the viscosity curve of a standard bitumen, and the medium blue curve shows the changes by Sazobit, which is viscosity reduction at high temperature of mixing and paving, and at surface temperature we obtain increased stiffness. Sazobit Redux has a different spectrum of effects. Excuse me. We also have viscosity reduction, but the crossover point is at much lower temperature, allowing compaction and rolling at lower temperatures. And there's almost no stiffening effect at the surface temperature range. Some data about this project. The asphalt was paved at about, excuse me, the asphalt was paved at about 130 degrees, and wearing cores as well as binder cores contained high percentages of reclaimed asphalt binder, 50% and even 60% in the binder cores. The fresh fraction contained bitumen 5070 and the organic additive Sazobit Redux, and the resulting content of the additive in the combined binder was between 1 and 1.25%. The diagrams shows results of compaction measurements. On the left-hand side, in situ measurements with a nuclear gauge. And we compare here the section with the organic additive with the section of foamed bitumen. And we can see that the section with the organic additive resulted in better compaction. Excuse me. Yeah, the same asphalt mix was used for lab compaction, which we can see on the right-hand side of this graph. Compaction was done with a Marshall compaction or with a gyration compaction. And this again resulted in better compactability with the organic additive. The deformation resistance was analyzed using the wheel tracking test in air at 50 degrees. The results show a more or less equivalent performance with slight benefits for the water foamed bitumen section. Aging behavior was tested by storing the asphalt mix in an oven at 85 degrees for 5 days. It was the same material from the job site. The stiffness was measured before and after aging using the indirect tensile stress method. And similar as in the wheel tracking test, the section with the foamed bitumen resulted in slightly better stiffness, but we also obtained more increase during aging. 30% increase was measured, and for the version with the organic additives, we had only 18% increase and 18% by aging. Yeah, the last figure I want to show is regarding the water sensitivity. This was investigated using the indirect tensile strength ratio before and after water storage of asphalt specimen. And in this case, we can see that the organic additive section resulted in much better performance, had less water sensitivity. Finally, my summary and conclusions. Coming back to the question of the beginning, is warm mix asphalt taking off now in Europe? My answer is a clear yes, because of following reasons. The social, political, environmental, and regulatory frameworks favor warm mix asphalt. The technologies are available and proven, and at least 20 to 30 degrees lower temperatures are possible without compromising the quality of the asphalt pavements. Warm mix asphalt reduces energy consumption and greenhouse gas emissions. More than 50% reduction of bitumen fume and aerosol emissions are documented. And the health and safety benefits will overcome the hindrance of high costs in Germany when the emission limits come in force in 2025. Experiences in some European countries have shown that if the authorities consider sustainability benefits in the tenders, the warm mix use is increasing. A growing number of countries issued, meanwhile, warm mix asphalt guidance documents and regulations. This is a very strong support for increased use of warm mix asphalt. We already see a growing warm mix asphalt usage in the last years, and I'm confident that this will increase. Thank you very much for your attention.
Thank you, Dr. Butz. Since there is some time left, you are kindly invited to raise questions. There are two experts with us, and we can use this opportunity. I can see you. It is still early. I have a question for Dr. Tušar to use this time. These graphic presentations were really excellent. And this composition of cannonballs attracted my attention immediately. But maybe those who are not so familiar with this field, can we compare these cannonballs? Well, can it happen with the asphalt mixture as well, so that everything is shattered? You know, when you try to excavate a bit of the pavement, what happens is that the crack can get wider, or you have poor quality pavement shoulders, and the cracks can appear, and these balls can slowly start to move, and then the effect is clear. Thank you. Maybe a question for Nika. Nika, if you could introduce one measure into an asphalt plant, what would that be? The most easily feasible would be to prevent or to protect the aggregate from moisture, to protect it from rainfall, for example. Do we have another brave person with a question? If not, then let us conclude this third section. And I would like to use this opportunity to thank you for your attention. And I would also like to thank the 3 paper presenters for their time and all the efforts invested.
Lepo pozdravljeni. Začenjamo z naslednjo točko današnjega programa in sicer na vrsti so
namely technical presentation of our companies and their products. Today it is CTS, EKOMINERAL, HSH, CHEMIE and FRAGMAT. I can see the representatives close next to me. I believe there is a lot of interesting information to share. I would like everybody to stick to the time allocated, 12-13 minutes each presenter, and then 1-2 minutes for Q&A. CTS, Mr. Blaž Gorički, please present your products and company. Hello, on my behalf, I'm coming from CTS Bitumen. My name is Blaž Bričko, sales manager for Slovenia and Croatia. Many of you know me, some are getting to know me today. I will present our company and 2 versions of our product. The registered office is in Germany, Bochum-Elbach, and our production is in Austria. In mid-18s, we started to deal with the bitumen modifications and rubber asphalts. It's a company with greatest experience in this field in Europe, modification with rubber. Initially, we used a known procedure, wet method. Technical performance was very convincing. The problem was handling and construction, because rubbered bitumen requires temperature higher than 200 degrees Celsius, and this also involved emissions and odor. CTS developed a new procedure. The product's been in use since 2005. It's granulate rubber modified. 2 versions, 4015 and 4020. 4015 can be used with all types of asphalt, and 4020 for the porous asphalt, drainage porous asphalt. As we all know, these rubber modified granulates can control, and we follow the curve of size particle distribution, as well as wheel track test. Polymers are dissolved during the production without wasting any sources. The responsibility is on the side of the producer and not the asphalt plant. No larger quantities of binder are required. Our philosophy is we want to positively contribute to the environment, and we wish to act in favor of the society. With our know-how and technology, we are leading in this field of technology. We supply the highest quality products to ensure longer lifespan. The advantages in this case, fewer construction sites, fewer administrative procedures, fewer accidents, and less CO2 emissions. As we all know, natural rubber gives bitumen the following properties: increased viscosity, increased softening point, improved properties in cold, improved dynamic load at low temperatures, increased elasticity, and increased adhesiveness. In practice, what about the practice? Here we end up with the following practical experience. There are a number of major surfaces already installed or paved. The average lifespan, 14-15 years. We go back to 1994, and there is one in BAB A96. No renovation required so far. Rubber binders and compliance, of course. Everything has to be in line with the regulation. Technical conditions have to be met. They are prescribed for rubber bitumen. These products have to be updated with long-term experience in the asphalt plant. They can be stored almost with unlimited period. No problems with recycling. We can add additives that affect viscosity. We have various well-established options of dosing. Very simple transport, trucks, railway, containers, bags, and clients can order also low quantities for testing. During the times of heroes, we created our own one, Bitumen. The entire process of our production, I will leave you with the cartoon a little bit longer. And the advantages of our product, our GRM, longer lifespan, durability of rubber-modified bitumen, we reduced noise, recycling option. The procedure of optimal viscosity is no longer needed. It is performed already in the production. This is what is added into the mixture. Flexible supply, simple handling and construction. And the topical issue, environmental balance. We save CO2 emissions, and if we talk about 10,000 square meters of asphalt in tons, we compared various products. So lifespan is similar to polymer bitumen, and per 10 tons of CO2 that we can save, well, we can save 70 tons. With a personal vehicle, we could go around the world 10 times, in our case, compared to 1.5 in the standard example. So we are located in Germany, Munich, but we are present in Germany, where the whole history started, as well as in Austria, Slovenia, Croatia, also Spain. And this is as much as I wanted to share with you, and I would like to thank you for your attention. Are there any questions for Mr. Vrečko? If not, let us continue. Let me invite a representative of HSH CHEMIE, Mr. Thielen.
Microphone, we are waiting for the sound, mostly since I want to present or introduce the Interchemica company. Some of you already know Interchemica. Others will soon get to know it with my help, of course. So, Mr. Šetina, please take the floor. Lep pozdrav vsem, moje ime je Michel Estefa in sem raziskovalec in vam bom predstavil predstavitev z naslovom Ekotrajnostne rešitve za asfalt skupaj s kolegom Fabricijem. Fabricio je imel nesrečo in sem ga nadomestil tukaj. In v svoji predstavitvi vam bom predstavil Interchemica SPA, to je podjetje, ki proizvaja asfaltne aditive in modifatorje. Locirani smo na severu Italije. Imamo 3 patente do sedaj. Winterpave, to je dodatek za samoadhezivne asfaltne mešanice, ki smo ga pred kratkim patentirali, ki temelji na nanografenu, in patent za procesiranje, predelavo in formulacijo trde plastike za uporabo modifatorjev v asfaltu. Sodelujemo seveda z vsemi italijanskimi univerzami in tudi številnimi drugimi mednarodnimi univerzami povsod po svetu, kjer predvsem magistrske študije ali doktorate pripravljajo študenti tudi v sodelovanju z našo družbo. In pri nas opravljajo tudi pripravništvo. Kar se tiče našega raziskovalnega sodelovanja, investiramo več kot 5% našega prometa samo v raziskave, v inovacije in v akademsko sodelovanje. Tako da, če imamo študente, jih z veseljem sprejmemo in podpremo njihovo raziskovanje. Če upoštevamo ta pristop na osnovi raziskovanja, lahko vidite tukaj nekaj posnetkov naših laboratorijev. Imamo najbolje opremljene laboratorije v Italiji in enega od najbolje opremljenih laboratorijev v Evropi. In s temi pomembnimi investicijami v raziskovalno akademsko sodelovanje nam to zagotavlja, nam in tudi našim klientom, ustrezno podporo projekta. Ta velik laboratorij, številni tehniki in strokovnjaki, ki delajo pri nas, lahko podpremo kliente ne samo skozi proizvode, ampak z znanjem.
To assure the clients, Interchemica owns a lot of national and of course international certificates. You can see some of them listed here. And of course, as INŠTITUT's slogan, we know how to go green. Then with additives to enhance the performance of the asphalt mixtures, less pavement interventions, and respecting circular economy, INŠTITUT helps the clients to produce more sustainable asphalt pavements. Starting by INŠTITUT lines, as I said, I'm going to introduce to you 8 main line of the products. The first line goes to asphalt modifiers, where using these asphalt modifiers to produce, mainly I would say are used via dry method. It enhanced the performance and durability of the asphalt, and of course with less maintenance interventions, you can reduce, as you can see here, not only the economic aspects but also the eco-friendly aspects. In this line, there are 3 main lines. As you can see here, Superplast, ITER PPS, and GPAVE. ITER PPS is a sort of a fiber which contains also asphalt modifiers. Then you can, using these special modified fibers, you can not only stabilize your Prus or SMA asphalt mixtures, but also modify it in a way. And GPAVE, which is a newly developed additive, which contains graphene and also hard recycled plastics. The second line is, of course, the hot topic of these days, recycling agents and rejuvenators. This slide shows how to use just 40%. Of course, 40% is not that much big. We should aim for to use more and more, but with this slide you can see just 40% of reclaimed asphalt, how much you can save with your energy resources and of course economic wise. In this line, there are several types of rejuvenators, and it can be divided in 2 lines of hot rejuvenators and cold recycling agents. In the hot rejuvenating agents line, there are several different types of rejuvenating agents, of course, depending on the type of the asphalt, quantity of reclaimed asphalt in your mixture, and also the type of the asphalt plan. And here I would like to mention this key point that INŠTITUT as a chemical company in this line especially concentrated to produce rejuvenators that not only recovers the physical properties but also recovers and restores the chemical properties of the aged bitumen within reclaimed asphalt. This would guarantee, of course, the durability and long-term performance of reclaimed asphalt. So please bear in mind that not all of the recycling agents can be considered as rejuvenators. This is what we always also discuss in IAPA. And on the other hand, in the cold recycling agents, there is a recycling agent to produce 100% reclaimed asphalt containing asphalt. This asphalt can be used for maintenance interventions, but also it can be used for cycling paths or even asphalt layer of secondary roads. This recycling agents can be used also with coloring materials to produce colorful recycling paths. That is a trend in Europe nowadays. The third line is dedicated to the warm mix asphalt additives. I would say is a very important and hot topic nowadays in Europe, and we are discussing in IAPA. So we have a technical committee working on these additives. INŠTITUT produces 4 different sort of warm mix additives. 2 of them are dedicated just for virgin asphalt mixtures, and 2 of them works not only as a warm mix additive, but also as a rejuvenating agent. So you can respond to several answers within your asphalt production. The fourth line is, of course, the anti-stripping agents as the main and the first product produced more than 50 years ago. INŠTITUT offers a wide range of anti-stripping agents from amino-based to bio-based and newly developed siloxane-based. The next is low-noise asphalt pavement additive, which are basically chrome rubber based. One of them provides also mechanical properties, but the second product, which so-called ether sealants, is specially treated and formulated to dramatically reduce the noise, especially for urban streets. The next is anti-smoke additives, which is a sort of additive that is sprayed on the surface of the asphalt pavements and improves the air quality using photocatalytic action. The next line is the next line is coloring materials. That in this line there are many different additives from paints, from mortars, from anti-corrosion or oxides and resins for different targets, for different places and asphalt mixtures. These additives can be used. Of course, as can be seen here, one of the trends here is to reduce using colorful asphalt, so to reduce the urban heats. And the last is the first patented product of INŠTITUT, which is winter pave. It is used worldwide. It has been used, this additive, successfully to provide safety during winter, and using this additive allows reducing or even not using in winter maintenance and intervention works, which actually is destructive to the environment. By this, I would conclude my presentation. Thank you for your attention. And if you have any questions, doubt, please contact me or my colleagues at INŠTITUT. And again, as a researcher, I would say that we welcome any collaboration and any even research or research work with academia. Thank you so much.
For the gentlemen, don't seem to be the case. FRAGMAT is the next company presented by Dr. Marko Mauri.
Lep pozdrav še v mojem imenu. Če se je prejšnji kandidat pohvalil, da ga nekateri že poznate, mene dvomim, da kdo pozna. Prihajam iz podjetja FRAGMAT, točneje iz FRAGMAT Team.
I'm coming from FRAGMAT from Croatia. We produce mainly construction materials, and maybe we are less known among you because you are primarily in road construction business. But we provide and produce thermal and hydro insulation. FRAGMAT team produces thermal insulation, hydro insulation. But to start from the beginning, let's touch upon the history. Bitumen hydro insulation started in 1937 when Anton Res established a company of roof tiles for roof tile production. Then another year is 1946. Izolirka company was established. In 1972, Team Laško followed. It emerged from the mining in Laško. Team Laško produces thermal and hydro insulation products. Then the next milestone was 1977. Team Laško opened a program of hydro insulation, starting with the bitumen insulation. The next milestone, 1991. After gaining independence, FRAGMAT company was founded in Metulje, Bloke, and the owner is the owner of Team Laško, Izolirka, and FRAGMAT team. We are not only present in Slovenia, but we also have a company in Serbia, Croatia, and Macedonia. The FRAGMAT brand is a synonym for quality and tradition. Our vision is to maintain our leading position in the offer of thermal insulation, hydro insulation, and packaging on the Slovenian market. We wish to increase the visibility of our brand and build long-term partnerships with business partners. There are several locations, as mentioned before, mainly in ex-Yugoslav republics. Production plants are in Ljubljana, where we produce thermal insulation and packaging, and also board heating. Laško packaging production, Croatia thermal insulation production and plates, Serbia thermal and hydro insulation, and in Macedonia thermal insulation production. As mentioned already, our sales program consists of construction products and packaging. Construction products, well, I am repeating myself, EPS thermal insulation, bitumen hydro insulation, and boards. Packaging program, EPS and EPP packaging and technical products for automotive industry. Since we are more focused on bitumen at this colloquium, this is mainly about bridge decks, where our bitumen hydro insulation is used. It protects facilities against water and moisture. They can sustain extreme weather conditions. They have a long lifespan, are simple to construct, not damaging for health. What types of bitumen hydro insulation do we produce? Overlays, bands, hydro insulation bands for foundations against floor moisture, pressing water, atmospheric conditions or impacts, hydro insulation of reservoirs and pools and bridges, viaducts. Our sales program, we could go case by case. Overlays, coatings, paste, secondary roofing, elastomeric bitumen bands, preventing water evaporating and moisture. And this is the meeting point, us and you. hydro insulation of parking lots, bridges, and we know that TPS document is being prepared, drafted at the Ministry of Infrastructure. There are systems that these are guidelines for contractors, asphalt providers, so what materials can be applied in certain segments. I am presenting a hydro insulation for parking lots, bridges. We talk about bitumen, coatings, bands. For road construction, we have the base. This can be concrete base, bridge, or maybe a kind of a plane. And onto this, we apply the primary layer. Epoxy can also be used. And then the binding layer, binding mass. In our case, it is called B2M, and then hydro insulation band, Isotec P5M. Polymer bitumen band that has been on the market for quite some time. This is not something new, and some of you are familiar with it. It has been installed quite often, but we have to be competitive with imported. We have to compete with imported products coming onto Slovenian market. Parking lots and bridges, the base has to be prepared, meaning that the concrete base is cleaned, epoxy and sand. Then we need to add hydro insulation, B2M, band, and then this hydro insulation has to be protected using asphalt or concrete. One of the program, bitumen emulsions, used in road construction and road renovation. Fresh, it ensures that fresh asphalt layer is well glued to the lower layer. This is the bridge in Krško, another bridge in the port of Koper, bypass at Bled, cycling bridge across the Savinja River, bridge in Marija Gradec, parking lot in Ljubljana, bridge in Ajdovščina, viaduct Žepina, and railway in the Gorinska region. There are other references. We are the producer of hydro insulation, so these are references mainly associated with road construction, but on the market we are also present in all other facilities. So let me present some of these facilities. Črni-Kal viaduct, our material, was constructed. Stožice, Nordic ski jumping center Planica, Congress Center Brdo pri Kranju, then local facilities, Termana Laško, hotel complex, spa Rimske Toplice, the museum in Ljubljana, ski resort Golte, Center of Space Technologies in Vitanje, and many more, blocks of flats and other buildings. This is everything I have prepared, and if there are any questions, I am available to respond.
Hvala lepa.
Thank you very much, Mr. Mauri. Any questions now? If not, Moving on. The last presentation will be about EKOMINERAL by Mr. Predrag Šinik. Please. Hello, also from my side. My name is Predrag Šinik, Technical Director in Nerinvest and EKOMINERAL companies, in charge, those who know me, for the operation of our quarry and all production activities that we have within our plant in Graš quarry for the production. Also, in part of asphalt mixtures in cooperation with Strabag. I will not present our company, but I want to present a product that came to the market through my efforts 20 years ago in Slovenia. This is flexible dilatation plate ANA. You probably ask or wonder, what is this connected? How is this connected to asphalt production, to asphalt? Well, for me, it was truly interesting how this plate was developed, for what it was developed. In 1990, it was developed in Austria, in Leuven University. Dr. Hackenberg developed it with his team in Austria in 1990s. They discovered that their biggest problem with shafts in the roads, how to repair the surrounding layers around the shafts in 5 or even 3 years. And the development, I have to say, they put a lot of energy into this work, a lot of testing, since the loads that happen on the road in the form of channel shafts are under huge traffic load, heavy loads. So first crack occur after 3 years and multiply in 3 to 4 years into this type of situation. You see cracks with higher leakage, frost around the shaft. And the solution was prepared in the sense how to connect the channel system, how to divide it from the pavement. So they developed flexible plates from strengthened with glass fibers in the size 1.4 meter diameter, with special reinforcements due to heavy loads that would happen with 80 kilometers, 40-ton truck that would run onto the shaft. We have huge momentary forces in classical construction. They pressure the whole shaft, the channel, the canals, and the under road structures. Here, with the plate that you will later see, what happens is that the cover of the shaft and the iron cover are glued to the plate, and the plate becomes part of the asphalt riding surface, which is quite easy. It's easy and simple when you see how it works, how it functions. But the key is that you always leave 5 centimeters of air between concrete part of the shaft and driving surface, and all the forces of traffic are transferred through this plate to the tampon layer of the road. This is a durable solution that is easy, simple in new construction with the system. It is quite easy to solve problems of settings, pre-settings to the level, the zero level of the asphalt, easily with the tampon layer. It is adapted without any unnecessary cutting, tampon bands and other issues that occur during construction, and it's very elegant solution in repairs as well, when we repair existing shafts. My findings in these 20 years were first shaft were installed 20 years ago at Ljubljanska Road in Celje, and when I monitored the situation through the years, I noticed some problems. The plate, in a way, in set segment is considered high-tech product due to its production process has a relevant price, and this is a moment that caused why I would install it if we have an established practice. I noticed also that perhaps this product in those years after 2000 came to the market too early. We were not ready for this high-tech product. But in this moment, things are changing. With installation of such plates, you can guarantee, I can guarantee you, you can avoid all unnecessary repairs for the period of 20 years. Lifespan of the plan is over 25 years. It can, if you remove the shaft from the road, the plate can be reused in other shafts after 10 years, which is quite interesting. If you imagine that you would need to repair the shaft from 4 to 5 years, the cost of repairs are reflected in your balance sheet. So it would pay out to use these plates. It corresponds to current goals to go into the roads, road surfaces that don't need repairs for 20+ years. In any case, deformations are prevented. Vertical movements with traffic is adapted to the asphalt surface, which means that we don't have pressure on damage on the road, a number of advantages that I might leave for some other time. It's easy to set the zero level in new constructions. And I also noticed through the years that we have quite a big problem. When we open the channel system, we don't have a uniform system of shafts. Plate was produced or made to the standard conus 60 diameter, and once we opened the shafts, we have meter, 0.8 meter, smaller than 60 centimeters. So in those cases, things are slightly complicated. In repair of the shaft, you have to fully open it to replace the cone, and then it's easy to repair it. But what I noticed is that this simplicity of installation and how you deal with the plate, it's problem with people on the ground when you repair the surface. It's too easy to be understood because people are used to complicated systems. And in case of installing this plate, You just need slight attention, preparation of the concrete layer. You will see in the presentation video, and all the rest is so easy and simple that you can't imagine how such an easy solution can have such a durability. This is a short video, a repair process of an old shaft, where this is a 60 diameter shaft. The iron cover is glued to this flexible plate a day in advance. This is how it looks. Two people easily place it on site. Nothing else is needed. You remove the concrete part of the classical system. You level the ground to minus 18 centimeters. Then you prepare the surroundings of the shaft. I recommend cement stabilization, slight cement stabilization, which would improve and repair the existent conditions. These repairs happen quite quickly. The biggest advantage is we have short roadblocks, and as soon as things are repaired, the traffic can flow back. It's repaired with classic process, no concrete, no fresh concrete. Anytime you need a fresh concrete, the road needs to be closed for at least 2 days to harden the concrete. The ground was ready, as you saw. This is how you see how the cover becomes part of the asphalt and drive-in construction. With the plate, all the forces, load, traffic load is transferred to the tampon layer, where we at the same time compress the surroundings of the shaft during its functionality. This is a repair where standard shafts have already been installed into the road. Imagine that if they are well organized with all materials, you can finish in 2 hours. It is done. I also noticed through last 20 years, the designers have problems understanding this plate. They cannot imagine how it would divide the shaft from the driving surface. And I noticed that they designed it with interesting technical solution, but they cannot combine with the plate. Therefore, we decided this year, since we believe now is the time to start with the new round of introducing this plate. Just if we calculate carbon footprint, this plate importantly reduces carbon footprint during the use of the roads. This was my brief presentation in the sense of this product that I see as the upgrade of high-quality asphalt work when we construct and repair our roads to avoid the nightmare of shaft repairs. This plate makes your life much easier. So we present it to the asphalt workers and not to the construction workers of the municipal Great. Congratulations for a wonderful event, good colloquium. We have a number of technical presentations for the next 3 years. So thank you very much for the invitation, and I thank you for your attention. Thank you very much. Questions for Mr. Šenik? Please. Yes, we have a question here in the front. The microphone. You can hear me? Construction Institute. My question is cost, of course. In the last presentation of this plate, how it would increase the initial investment if we would use these plates, and what are the final savings? So financials, please. Well, final price without the cover is roughly 450 euros. If we deduct classical concrete band, this initial investment is 350 euros. If we consider additional complications in presetting to the zero level, perhaps complications also in installing the asphalt, in paving. There are some problems with shafts that usually we do not calculate in advance. These are costs of people working in the moment. The initial investment compared to the current practice, current alternatives, is 250 euros. And if we start calculation repairs and lifespan and other factors, the savings in 20 or 15 years is roughly 5,000 euro. Yes. We have a problem that initially it costs us more, but in long term we have huge savings. Thank you. I would ask Mr. from CTS, since we have a large number of companies that supply additives for the so-called rubber bitumen that would reduce the noise, what would be your advantages? Why the operators or clients would decide for your product? We know that we modestly start with these sections to reduce the noise. We will have to do that more in the future. So why we should choose your product? Thank you for your question. As I mentioned before, advantages are longer lifespan compared to polymer bitumens. It has been proven, also tested in practice, our lifespan is longer by 30 to 40%. Also in noise due to the rubber, you can see the difference. Mostly, we have some anti-noise tests that we've performed. We can send you all the results and you can check our references, carbon footprint. We have huge advantage here with comparison to polymer bitumen. This is it. In comparison to mastic bitumen, we don't have problems in ordering, in storing. We know that mastic bitumen has to be stored in the right dosages. If we order it not enough or too much, we are in problem. With us, there is no problem because you can stock it up and store and order our granulate in different packages. We deliver it, store it. We are very flexible. We will welcome any cooperation and any question, of course. Any other questions?
If not, let me ask. I know that you've been trying to bring this technology into Slovenia and that there have been some test fields, but no common use, no broader use. So where do you believe the shift should be made? Asphalt producers, contracting authorities, clients, how to achieve this breakthrough? Thank you for your question. So this is a quite topical issue, rubber asphalt. We mentioned it on Wednesday and talked about as well. The problem of new markets is that the initial price is higher compared to polymer bitumen, but taking into account the entire lifespan, we are actually the cheapest option, the cheapest producer having this offer. We commissioned a study in Germany. We also work on anti-aging tests. I can present it on the next colloquium, or I can provide information prior to that. I can inform people at some institutes. It seems that EU is also inclined to go into this direction, and our advantage is because we've been working on this for some years, and in Germany maybe the progress is made a bit faster, but I can see that in Slovenia a lot of efforts have been invested also based on the assistance of ZAS. We've been a member for 3 years, and we intend and hope to maintain this membership in the future as well. To conclude, we can say that there have been interesting presentations of products that will be useful in the future, and let me thank the representatives once again. We would like to thank you. Thus, we have come to the end, but we will continue right away. So let me invite all the presenters in the last section. My mistake, it's a half an hour break. Welcome, everybody. I'm glad that there are quite some participants who have stayed with us to listen to the last section number 4, Design, Construction and Maintenance of Asphalt Pavement Structures. The first will be presented by Stepan Bohuš from Czechia. Mr. Bohuš, you are kindly invited to take the floor. Mr. Bohuš is in research and transfer of research results into practice. Today he will be discussing the pavement reinforcement.
Okay. Dobar dan. Hello. Sorry about my Slovenian, Croatian, Serbian language. I was speaking English, unfortunately. Thank you for a really nice conference and all of you staying for such a long time. It's not very typical for conferences. On a Friday, everybody leaves in the morning, so I'm really happy we can spend a couple of minutes together. I was very pleased to hear there's a lot of topics running around CO2 reduction, emissions, but also very good discussion about the quality, about the performance. It's not only about the reduce something on the hands of other properties. A lot of was discussed to add extra for the bitumen, how we can perform the better construction for the long periods. And today I will have a short presentation based on a research which is done in a Czech University in Brno. It's a second year of the research, so it's a part of the results we are coming. And it's focused on a structural, let's say, reinforcing the layers of the asphalt, the principle of prolonging the life. And one of the key subjects in the presentation will be how these layers function, bonding and compaction with such a technology together to really get the best results on the ground. So, I will talk about the subjects I introduced, how the cracking and our problems are appearing in the roads. You drive as a user and you see easily a lot of cracks, people are stopping, we need to repair. So how we get them? The benefits of using, let's say, extra interlayer in our systems, which is not very traditional in several markets, yes, but I would say in a worldwide basis where we operate or where I am active, the technology has certain uses, but very limited normative background. Performance and of course the conclusion. So if you talk about the technology generally speaking, there is already 30 years use of it. So numerous producers have different technologies which bringing from 3 to 5% prolonging of your cracking performance of the structures. So one side is to improve, let's say, the bitumen layers with the additives and different granulates and etc., etc. Other is to introduce certain layer in between when you rehabilitate or you build a new structure. What is definitely not for today, these subjects. We will not talk about the geological subbases, really critical structural problems, and we don't talk how we started with the asphalt and tar in the beginning. But what is definitely for today is a little bit of history. When I look how the business basically started, the oldest road was built 4,000 years ago in Middle East, in Giza. Pavement, let's say, or how we can call pavement. About the tar, when we talk about the tar first applications, you can get on numbers of 8th century, which was also in the Middle East. The sources of the material were used, but we could not talk about a very, let's say, systematic approach. They apply something on the ground, and then coming higher problems with use. And in Europe and America, tar was basically applied by 18th century, and then grow, numerous regions and use, and within even a design. Today I want to talk about the modern design as we know it. So whatever we do in a structure, which is rigid, semi-rigid pavements, let's say, the cracks are appearing. No matter what we do, we are receiving such thing which is called the reflective cracking. So from the sub-bases, by years of use, you get the cracks coming up on the top. And by the different technologies on the ground, let's say the concrete use, or slabs, or you have a different passage through the asphalt, you get a crack going through. So you see some main topics on the side, extension of the roads, etc. What is related to? It's everything we discuss. The traffic is growing in our roads. We hear the number 15% in a couple of years. We say 2% in average in Europe, in standard roads. So our design we are using, and there was a really review of ZAS a couple of years ago about design. When you look on the Europe, it's different thicknesses, different materials are used. At the end, the problem remains in a different region. So you have a temperature cycles, and you have a lot of traffic coming on your roads. And I'm talking about heavy traffic, not about the regular cars. I'm talking about the big trailers moving the goods, which are really impacting our pavements. And of course, you can have a sub-base movements, which, to be very open, we have so many roads, we can rebuild them from scratch. They were built 30, 40 years ago with certain parameters from the ground, and we need to work basically on the top layers to try to maintain our network. So on the left side, you see the basic movements, what happening in the structure, which is shear, sliding and a temperature cycling. All of them together with the traffic, they damage your roads. If you find in the literature, it says that the average crack from the ground grows from 1 to 3 centimeters in average per year. So depending on the structure and depending on the problems, you are only waiting when this subject will appear, basically on your upper levels. What you can do is, when you rehabilitate all the building your road, you design your layers to be resilient against the cracking. In a first moment, in rehabilitation, you are quite limited. You are coming to the structures which you can remove 2 layers, for example, no more. Or the budget, or the construction constraints. And then you are sure that all the cracks are basically on a sub-base and they will reappear again. So interlayer system works. In between of asphaltic layer, you place reinforcement. It can be from different materials. Today we'll talk about the glass fiber products. And here you can see easily on the 3 types of structures we have. On a concrete, let's say rigid pavements, you cannot use interlayers. There is no interlayer. There is a concrete structure and that's it. Of course, you use with bond. But when you have old rigid pavements which are rehabilitated to be, let's say, semi-rigid, then you're already introducing the asphalt and the interlayer, the space where you can enter the new products who will stop your cracking to reappear. And surely the flexible, which is the most of the roads in Europe, then you can apply in a different layers, in a different depth of your structure, the reinforcement, let's say with a different function. The benefits generally on all the products, depending on the producer, depending on a type of material. Applications are roads, airports, tram lines in the cities, etc. So the use is really wide. Everything related to the asphalt, not talking about the concrete. And related to performance, there is clearly stated in a lot of papers in European science, 3 to 5 times you prolong the life of your road, of your pavement. It's immediately impacting the costs, the long-term cost of your rehabilitation. Safer roads, so you don't have potholes and etc. But all this, it's related with how we normalize and how we use these products. I just outlined what is really in that matter. All of you are very familiar with the bitumen. We talk about a lot how to do the mixes. But with the geosynthetics, there is very few norms and normatives in European standards. So you have EN norm 15381, which basically tells you what is the reinforcement for asphalt, okay? How it's produced and basic parameters, but nothing more. It just controls the producers to say what parameters they declare and what parameters you basically receive from the laboratory. Let's be very open. From the laboratory which is tested for your proof for the state. Then you have a national standards depending on the countries. In Germany, FGSV, DAF Institute is working on a new standards in France, Slovak, Czech Republic. But they are really national. In, I would say, Adriatic regions, they are not existing. I don't know about any which is really regulating the way of installing the products, which is a good sign now. On a level of CEN, on the high European Commission, there is now being created ISO norm, which is related to design, because ISO is related more to design, how to use reinforcement for the pavements, which products, to which depth, and how they function. what I want to say, you have basically three functions: reinforcement, stress relief, and waterproofing for your construction, which you can introduce. If you see it in a very simple way, the reinforcement are grids, and everything else with the stress relief and a barrier needs to be grid attached to certain non-woven. What it means in practice, on the left side you have a grid which you on a job site apply or with the adhesive glue, so the roll is applied by the roller you go through, or it's a pure grid, means it's a mesh. You need to use the nails to shoot them down on a job site to attach, to be able to apply the extra mass. And if there is a non-woven, the product is applied, you spray the emulsion, you drive immediately behind it with the product, it saturates the emulsion, and this will basically stick to the ground and later will secure the bond of the layers. So, just very briefly to say, these are the parameters by the norm. They are not really talking about which products and how to apply. And this is something which producers are recommending, needs to be followed, but it's not really regulated. And today I will show you the results of the paper published last week in an Asphalt conference in České Budějovice. Yesterday, Mr. Svoboda talked about the conference, published on the research of 2 years with the university, related to bonding and the compaction impact on the performance. So first of all, the main subject was, there is no regulated what kind of tack coat, what kind of bitumen you should use for interlayer. In the regular projects, you can basically use whatever tack coat you can use. In interlayers, there is very important to use the tack coats with a high level of solids. So here you see on the graph, from left side it's going 50 to 70% solid emulsion, so 50 to 70. There others are not really produced in European. Cationic, polymeric modified. And you see results of the bond, how it's growing. And I also marked two chapters, which is 15 and 12 kilonewtons. So if you're familiar with the testing on the job site, you drill the cores, you need to share them by the Lorton test and to receive the value. Then you basically approve. It's most of the European countries really control that parameter on the job site. It's a bond of the layers. And strongly related means needs to be designed with a higher, even with a tack coat related to the product for your projects. What it brings you as adhesion, it's a growth of adhesion for the final project, surely. It shortens times for curing. So when you apply something with the less water, basically, it evaporates faster, you can install and do the job faster. And the dosage you apply on the job site, there is more control. Less water, less flowing outside, less flow into the sub-bases. It is the first outcome of it. Then was compared what happening when you install the regular grid without any adhesion layer. You shoot it by the nails, and basically you apply the asphalt over. And then compared to self-adhesive solution, where you have basically glue and really attached to the ground. And you clearly see that installation on that matter is bringing higher performance for bond. Because of uniformity of application, you get 17 to 25% depending on the type of emulsion. I showed the lowest one. Related to the installation and final performance. On the left side, you see how it looks when you run with the paver over it. On the opposite side, when you don't have the really attached grids to the ground, they are picked up by the trucks, by the lorries, during even the paving process, and they can be removed, which is immediately impacting the final result. So we're talking about the performance on the job site. Important side here I show, there are two applications. So in the first case, when we talk about the design, you can design, let's say, leveling course, the flat surface, or you have 2 layers of asphalt where the grid can be attached because it's flat. Okay, one solution, it's more layers. But the second subject is when you cannot do it, or you have milled surface, which is very rough. You cannot put any grid on it which is pure, because it doesn't stick to anything. It needs to be used with the non-woven. So you see 3 steps. On the first one with self-adhesive, basically applying grid, with the drum roller you drive 1 time there and back, and you can immediately pave. On a composites, they are working that you need to spray emulsion, and immediately behind the spray tanker, you go with a material which saturates the bitumen, and it's going to be stick on a way as you see on the ground. At the end, for the bonding, if you see, if there is a nothing for the flat surface, it's a yellow and milled, it's on a yellow, and the blue ones are showing to you when it's applied on a flat or milled with the right application, a right amount of emulsion. So, as a result is you achieve the bonding with the right amount and the right product on the job site. This is coming from the research, but needs to be really followed. And this is very important graph if you look on it, because your performance is always related to the compaction level. Here was tested how the performance of the product of the bond is related to the compaction. So on the red dots, you see the structure without any reinforcement. The blue one is showing to a self-adhesive grid and on a flat surface, and the composite on a green one. What you see is from 96 to 100% compaction. If there is a wrong procedure to compact, wrong material, then you get subject not really meeting in a lower level, the compaction level, and then the bonding and the performance. And here, if you look on the number on the X set, with the 100% of compaction, the self-adhesive are showing the higher bond strength on your structure because of uniformity of the design, let's say, of the whole system. So to be very brief, this was the just outline for one of the parameters which you can follow on the job site. And the recommendation is to use the right products on the job site to discuss and talk with the producers for your projects, because there is various products on the job sites. Paper and research says no pure grids should be used in asphalt because they are having issues with installation. Should be or with the self-adhesive or with the light non-woven to be able to apply it. Emulsions must be 60% minimum of solids, 65 is recommended to really write in the design when you tender the project to be followed by contractor. Polymer modified, of course, when you have a structure with polymer bitumens and so on, and follow the extended recommendations because many products are applied, and it's very individual for certain of them how they need to be applied. Basically, it's it from my overview of reinforcement and structure. Thank you very much.
Thank you for a very interesting presentation. Is there any question for Mr. Bohuš from the audience? If not, okay, let's move on. Next presentation, prepared by Zvonimir Britovšek and Roman Kugler, construction of green roads. Mr. Britovšek, please take the floor. Yesterday and today you could see among technical presentations our efforts to protect the environment and our health and workers' health as well. So this presentation is also focused on the protection of environment and contribution of asphalt industry to solve these questions. The content is, first, we will start with general topic about environment and asphalt, use of rubber granulate, testing field together with road celje, and some conclusions. Started with the general problems. We started with climate change. Unfortunately, we live in times where we have frequent extreme weather conditions, a lot of precipitations, green, brown winters, environmental temperature is rising too quickly, too fast, and the question is what follows. So this is all connected to green gas emissions. We are discussing carbon footprint, and looking at this curve, until pre-industrial age, the concentration of CO2 molecules in the air was around 280 ppm, and now we are at 415. We've had a number of environmental conferences in between, but none could reverse the trend. Where are we as the asphalt industry? We are partly located in industry, partly in transport. Our cumulative impact is roughly 35%, so a third. This is the chart showing the impact in the emissions of greengrass emissions from different geographical areas. Until 1990, the annual emissions have doubled since 1990. From 20 billion ton equivalent CO2, we are today at 35 billion tons. Another problem that is caused by humans with our industrial processes and other activities, we generate a lot of waste, municipal waste, construction waste, and they should represent potential raw materials. All these things, this reuse of alternative materials can be used in production of asphalt, waste also from other industries. Noise that in principle we don't see as a pollution yet, but it causes strong negative effects on people, on animals. Sound effects in different forms we accept through skin and through our hearing. It causes physiological changes that are expressed in different forms of stress and other factors. And let me also introduce a number of environmental conferences and their results of political agreements in the past. And let's begin with those. The first relatively large conference was in 1972 in Stockholm. Around 120 countries adopted non-binding measures at that time with modest suggestions that we are causing climate change, we are those generating green gas emissions, and at the 20th anniversary of Stockholm, we got Rio conference with some binding measures on reducing green gas emissions. I believe they were discussing 20% at the time within 20 years. Then Kyoto reached new agreement, but all these international conflicts were represented and reflected in Kyoto Agreement, where it was signed only in 2006 with the signature of Russia as well. Then Paris conference in 2015, where European Union was highly interested to reduce these harmful emissions. And 14 days ago, I believe we wrapped up the Glasgow conference with decisions, more binding decisions, but still some countries like China, Australia, and India, in a way, were against their obligations, against cuts in fossil fuels and coal. Coal, at the moment, represents the majority of their production and energy source, productions of electricity. And looking at this curve, you can see that green gas emissions are still growing, and the perspective after 2020, 30, or 40 should be a constant growth, or should be a level line. We should keep the emissions at the same level, meaning that self-cleaning capacity of the earth would be such that would stop this growth. But looking at particular curves, we can see that in some countries, great polluters, the curves are not declining. In some are declining, in some are not declining. We are talking about active reductions, but on the other side, we have India and China with strong growth. They advocate their position that the developed countries can focus on that since they are already developed, but we still have to develop. Comparing the emissions from 2007 and 2018, the table shows in 2007 the biggest polluters were USA, Europe, Russia. China was hidden in Southeast Asia, India, and so forth. In 2018, things have changed. US is on the second place, Europe is third, but now China is on the top. In between, the total quantity of emissions has grown by in the factor 2 times. So relative shares are interesting, but absolute values have grown. And this is one of the main conditions why we cannot stop the emissions. Also, Brazil and Indonesia are interesting here at the bottom. They are big polluters. They develop their industries. And on the other side, they are cutting their rainforests that were used sometimes called lungs of the world, so we are reducing the absorption capacity of the planet as well. This is the image showing easy arguments of non-developed countries. Check the emissions per person, and China, India, we can add Pakistan. Also, they are quite low with emissions per capita, but we have to say that half of the people live there, 3 billion people, so we cannot have comparable data. We are blaming each other and cannot agree on what should be done. But moving to asphalt and environment, what can we do with efficient energy use? In a way, we adapt energy sources that we are using. We insulate our production systems. We optimize fuel use in transport and in installations. We have to reduce the temperatures in production and in placement. We have foamed bitumen technologies. They are not as frequently used and as actively used as we wish. And then we have some additives, waxes, zeolites. They provide lower temperatures at pavements. We also can use secondary raw materials like granulates, used tires, as I mentioned before, organic additives, slag, and reuse of asphalt. We heard yesterday we have only one asphalt plant with hot parallel drum. I believe six plants can dose the granulate in cold setting, but we still have a lot of room and possibility to use asphalt granulate to a larger extent. We also have asphalt mixtures that can reduce the noise, the use of fuels, and we can build more resistant, durable roads with new technologies, and we have to raise the quality. Looking at the waste tires, practically billion pieces of waste tires is annually generated, and we have to remove them one way or the other. 60% are being used as alternative fuels in cement industry with high heating value, high burning value. 25% are used for processing for different forms of granulates. and in construction, in asphalt as well. The remaining part in recycling of waste tires is less than %. And now, how we can use this granulate in asphalt? We have two ways: wet process. We are talking about rubber-modified bitumen, and dry process, where we use the rubber-modified granulate. Reasons why we decided to build this testing field are environmental mostly. Good experience from abroad as well. We don't have our own experience, with exception of few motorway testing fields where we repaired former or removed toll booths, and we installed open-graded rubber asphalt. We brought in modified bitumen, and this was a wet process. One of the goals is to find new solutions, of course. And now we leaned also to the information from abroad. Noise reduction is noted. The amount that I will present today, this is the classic asphalt concrete. The savings there, or noise reduction, is by 2 decibels. What does it mean? This is the chart from, I believe, 15 years ago, when we were dealing with noise load, and you can see that the reduction by 3 decibels means real cut of traffic by 50%. So if we reduce the noise by 2 decibels, it's like we would reduce traffic by 30%. So it's not neglectable. It's an important logarithmic relationship. Durability, slower aging of these asphalts, according to the performed measurements and producer information, it's between 25 and 50%. And altogether, this leads to the lower carbon footprint, lower need for maintenance, and higher economics. We invest less energy compared to classic asphalts. Here you will see that with 2 rollers we achieved the same compactions. There is enough time for compaction, and the rest, lower costs, is also connected to durability. In this testing field, when we were looking for location, we were quite lucky since the Celje operator last year started with the reconstruction of a kilometer of regional road 245 between Velenje and Celje. This road is located at the northern part of sleeping settlement Pesje. On one side we have relatively big industrial zone between Velenje and Šoštan. 500 meters to the east we have Gorenje with additional industrial road. So this was highly burdened road with heavy trucks. We expect the third developmental axis track also nearby, so this will be a very burdened road with heavy traffic trucks, heavy trucks. So this was quite appropriate location. We were lucky. So Butz, we say, was the operator, and they were very willing and ready to test this new technology. They already had experience with the rubber asphalt following the wet process, and since they knew some problems in supply of bitumen and in logistics, they also decided to try this dry process, which is much easier in case of dosing, and things they believe will, or in the future, automate the process, which would simplify all the process. They had to get the approval from the investor, from our motorway company, or a road agency, and according to the specification, we prepared all the documentation. We presented the case to the agency with the contract custodian. We confirmed the funding, and we started with this testing field. The choice of mixture, since the location was the industrial area, we decided to use less noisy asphalt, AC with polymer modified binders was the planned material, but we replaced it with bitumen with rubber granulate. As I said, we had used the dry process and the implementation. Here you can see we were working in relatively favorable weather conditions with semi-closed traffic, quite heavy traffic on the other lane. And these are some interesting views. Look towards Šoštanj, thermal power plant, block 5 that should be closed, block 6, and to the right, the old separation of the Velenje coal mine. They no longer separated, but they transported directly to the depots. With heavy rollers, we compacted the whole track with finisher, and with the smaller roller, we managed the special details. And this is the photo looking towards Gorenje. This is the track for the third axis, so this will be a heavy loaded road. Measurements were performed first. We had internal testing field close to the asphalt plant in Shantianj, in Koroška region. They also sampled the asphalt mixture. IGMAT tested the samples with tire track tests as well. And here, for your comparison, you can see the test that was made on the core samples taken from the testing field. According to the measurements were performed by the operator's laboratory within internal control. Here you can see the changes in input bitumen, extracted and installed bitumen. Everything was according to the technical specifications. Then we compared, performed comparative tests on water resistance, and we suggested also Marshall tests to be done. It's no longer being done for asphalt mixtures for road program, but we said at the end of time we will use this for the monitoring, and the Marshall test, I believe, is good indicator showing changes in bitumen in the asphalt mixture. And right top, the analysis of all mixtures, and you can see great correlation in the content of bitumen and open cavities. For the conclusion, goals that we are following are reducing use of natural resources, zero waste. This is the ideal that we will probably never achieve, but we can come close. Lower energy consumption, this is imperative for all of us, mostly even more developed, reducing all harmful emissions to protect the health of our workers. Also, carbon neutrality. We heard a lot about it yesterday. By 2040, this is our goal. EIAPA said that this is their direction as well. Lower noise. We have to reduce the stress for people and animals. And how to reach these goals? I believe we need absolute support from the investors. Yesterday, I have to say that I listened to our state secretary, who was fully supportive on behalf of the ministry. Then explicitly support was declared from the representatives of the agency and Slovenian motorway company. But now we have to increase this support through legislation as well. Not all the burden should be assumed by operators in any way, shape, or form. This is simply introduction of new technologies that require investment and funding as well. And we have to be firm in asking for this support. Operators have to decide to start with these new projects. They need to invest and modernize their equipment and their plants. We have to increase investment into people. We don't have them enough, and we need to keep them. Digitalization is our way of life already today. Higher quality is very important for all of us to reach these goals, for all the stakeholders. And the final result is sustainable development and protection of environment. We were talking about Vision Asphalt 4.0 or 0.4. There is no dilemma. There should be no dilemma in that. If we wish to preserve some dying species, biodiversity for our children, for future generations, if we want to provide their future, not to become one of these endangered species, we should do our best. Thank you very much. If you have any questions about the production or installment, we have Mr. Kugler also here ready for questions.
I see there are no questions, but I can make a comment. I'm not sure I would... Okay. I don't think I would miss urchins that were also in one of the photos. Now, the next presenter is Mr. Marjan Marolt, the analysis of the reasonableness of the use of single running surfaces on all lanes. Thank you very much once again. All those who have been with us till the end, so this is the very last paper, and we will present the development research task focusing on the analysis of the reasonableness of the use of single running surfaces on all lanes. This task was commissioned by the motorway company, and it was taken over by the ZAS, the Slovenian Asphalt Pavement Association. Slovenko Henningman and Luka Matjaž were involved. In Slovenia, we have different lanes of different thickness and quality. On the one hand, this is logical, because there are different loads on different sections. And on the other hand, there is a question posed in professional public whether this is most optimal and whether it wouldn't be reasonable to use single running surfaces. And this task should provide an answer to this question. We obtained some guidelines, orientations, what to deal with. So we provided an overview of the implementation of pavements in Slovenian motorways and speed roads, express roads. Then we examined the regulation, what is used in the neighboring countries, who we often use as a model. Then we compared various versions of the implementation of pavement structures with the implementation of a single running surface. We also compared benefits and disadvantages or shortcomings of all implementations, and then we drew conclusions and recommendations. The first motorway, if we can call it, it was the road of brotherhood and unity. It connected the north and the south of our former Yugoslavia. It was concrete with some individual sections made of asphalt, and in some cases there were cubes, granite cubes. Asphalt layers, two thin layers, binding and the wearing course, 3 plus 3 centimeters, and then above the 8 centimeters of crushed stone. There were thinner asphalt layers because of the capacities of the production plants then. This was constructed in the 50s of the previous century. The first motorway, it is the road of brotherhood and unity, Ljubljana-Zagreb. But then the first modern motorway was the section from Vrhnika and Postojna, motorway section, constructed in 1972. This is a much different structure, quite similar to what we have today. And for the then traffic loads, quite thick asphalt layers. A picture from those days. In the 80s, the first sections of the Ljubljana ring were constructed, and the connection between Ljubljana and Kranj in 1985. And also later on, in the period of the 90s, when we started with our national motorway construction program, this was the structure. For each lane, we used and determined the traffic load, and based on that, the structure, the pavement structure was defined. There were no lower limits defined. After 1999, this was the pavements were partly standardized because of the technological issues that the operators had. Therefore, the load-bearing layer was added, and another layer was added to the emergency lane as well as to the main lane. In 2000 and later, especially when Slovenia joined the EU, we recorded increasing traffic load. The implementation of renovation works was very difficult because of the increasing traffic load, and this is when a decision was taken to increase the thickness of individual layers. But we kept this separate profile of individual lanes, the emergency, main, and overtaking lanes. These tasks also involved the examination of domestic and foreign professional literature. In Slovenia, we have technical specifications that we use, technical specifications for determining traffic load, and then 2 technical specifications for designing and sizing of new pavements or the renewal of the existing ones on the basis of the traffic load of an individual lane. The structure is determined, the layers are determined, and this is the basis for further design. And thus, we have different structures under individual types of lanes. In Austria, for example, this is a specification, a regulation defining the calculation of traffic load, and there is also a catalog of standardized pavement structures for asphalt services and 10 for concrete services and 4 for paved surfaces, and they can select a specific structure for an individual section. Then they also include braking and accelerating lanes. So they take the same structure as for the main lane, or they reduce it by 1 degree. As for emergency lanes, for the reason of implementation, this is identical to the main lane when it comes to motorways. Similar situation is in Germany. They also use catalogs of pavements. For other traffic surfaces, the same or similar regulations apply. They also construct different pavements, and the emergency lane structure is usually identical to the main lane. So these catalogs somehow simplify the designing process, and it's important to stress that emergency lanes in both countries are designed and constructed using the same structure as with overtaking lanes or main lanes. Further on, we also compared the costs of different systems, of different structures. Namely, we wanted to know what it means, what unification would mean, how the cost of construction would, how much it would cost, and how the whole investment value would increase. So the average value of investment in Slovenia was 11 million euro per kilometer. And we didn't take into account a potential expansion of the
pavement. We only focused on the individual layers. We took into account the sections actually worked on. Slivnica-Draženci section, 3 versions. This was a new construction, renewal section, Ljubljana ring renovation, 3 versions, and 2 examples of upgrading the pavement, reinforcement, Brezje pod Tabor, the Gorenska region, Slivnica-Draženci section A4. This is the cross-section of this section. Probably this scheme will tell you more, the thickness of layers performed, and we also see different layers. For this section, the costs of the construction of 1 kilometer was calculated, and then we partly unified the load-bearing layer, so we have single running surface and perform the calculation, and then so partial and then full unification. If we take a look at all these calculations, we see that per 1 kilometer of motorways, I'm talking about the implementation cost. Partial unification, it increases slightly, and full unification, 60,000 euro increase. Now, if we take a look at this table, we see that this increase ranges from 6 to 16%. So this is the cost related to the top structure. Now, if we take the average value of 1 kilometer, we see that this percentage is significantly lower, ranging from 0.5 to 1.4%. Then also the renewal. This is the cross-section of the Ljubljana ring, a scheme. This is a case of a single running surface. The wearing course 4 centimeters, then 12 centimeter layer, and the binding layer on the existing cement layer. The cost of the implementation for 1 kilometer. And then we compared the savings in the case of the implementation. In this case, the emergency lane would use carbonate materials or applying the separate profile. The comparison reveals that the savings in the first case would be 1.3, and in the second case 17%. And if we take a look at the entire investment regarding the renovation, 3.2 million in this case, the increase is significantly lower, up to maximum 5%. Then 2 resurfacing cases were compared. Also, in this case, costs increase by a bit more because these are smaller interventions, but we go up to 5%. Also, in these 2 cases. Cost comparison and conclusions. A single running surface increases the cost of the implementation by 10 to 20%. But if we take a look at the entire investment, this only accounts for 1 to 2%. And I have to stress that the expansion of the emergency lane was not
taken into consideration. We also compared the advantages and disadvantages of single running surfaces. Minuses, disadvantages, damage that we can see on motorways, on emergency lanes because of the traffic. We often see cargo trucks driving across this line. The traffic is directed to the emergency lane whenever there are closures or accidents. It's redirected. And in the case of interventions, the intervention corridor needs to be established. There are lower friction properties of emergency lanes because carbonate stone is used, and heterogeneity of the profile of motorway can be disturbing. 1/4 of routes already have single running surface, all accelerating lanes, all drainage fields as well, accelerating and braking lanes. So this might be a visual disturbance. And the contact that appears if the implementation is not top quality. Renewals also experience some problems, uneven wearing of individual traffic lanes. So in some cases, renovation is needed earlier. If we only renew the main lane, which happens, because of the shift of load, we also have to deal with the emergency lanes. In situ technologies are more difficult to use. In case of expansion or changing, and also logistics is more demanding. And as regards the standstills and delays, this emergency lane is then used for traffic, or we cause standstills. Sometimes we first need to remediate the emergency lane so it can be used for traffic. Of course, there are also pluses. Lower initial cost. Initial is underlined because it's a question what it means for the entire lifespan. Stone grains of domestic origin can be used. We can use softer binders when it comes to emergency lanes. I talked about different color of surfaces. This can also be a favorable property. Construction capacity can increase if we use different asphalt layers because we obtain the material from 2 asphalt plants. To conclude, this was also our proposal to the board of the motorway company. With new constructions and renovations, single running surfaces should be introduced. This would mean an increased cost with new construction 1 to 2% and with renewals up to 5% of the average value of investments. The single running surface introduces more benefits than weaknesses. This can also be proved with the experience from the neighboring countries. I am open for your questions together with my colleagues who were engaged in this task. Any question for Mr. Marolt? If not, I have a question, namely, in light of the finding that the uniform running surface makes sense, do you believe that it makes sense the resurfacing the whole width? What is your opinion? Yes, we started discussing this topic as well. The fact is that we are slightly more skeptical because we know that you are talking about one plate, one single plate. Here we know that this is quite an expensive technology, that we have to manage it. So here I think that this is not the most important issue, but also in the way how we do now, we need a single uniform composition. That's the main issue. Thank you. This concludes the last section, and now it's time for the conclusion of the colloquium. So, Slovenko, please, you are the last person to take the floor. Thank you very much. I have some notes. I have 5 more minutes. We want to wrap up on time, so according to our habit, we use a lot of statistics in ZAS, in asphalt industry. It's good to know what your numbers are. So let me, in the beginning, few numbers. At the 18th Colloquium, we had 18 professional presentations, 14 live, 4 online, 8 presentations of companies, 7 live, 1 online, 7 introductory speeches, 6+1, a very important 2 meetings before the colloquium on Wednesday. First, the meeting with the ministry, ZAS, and Slovenia Motorway Company, and IAPA, and business partners, and then the meeting of the Board of Companies. And we had 70 representatives attending these 2 meetings. I believe it is really important to work industry with administration, with contracting authorities. We were praised for this practice. Then we opened our exhibition space. We saw great exhibition space during the break. Not a lot has happened since the lobby of the hotel is very pleasant and nice space. We had special award of recognitions. I believe it's great to have it here, not at dinner time, and I believe we were quite successful in this move. 215 from 8 countries people were staying at the hotel here, and then 30 online live stream. We are digitalizing our industry. We will also digitalize our events. Not everything will happen live. The trend is moving into hybrid system, live event with online participation as well. Otherwise, we follow our classical approach. We still print our materials. You have professional articles. You know, when you look back, when you want to see something, you find it best in your book. We are discussing a lot in our management board. We don't need to change everything. We keep this publication live. So this is our tradition, and we try to hold on to it. We have provided live implementation with additional testing. No case of infection was detected. Let's stay healthy, knock on wood, with this great effort made successfully. Looking at what would be a professional summary of these 3 days, definitely. Environmental topic is the dominating one.
reducing energy use, reducing all types of emissions, and we all have to do our best to reduce the negative impact and preserve our Earth. The requirement or request from Germany to cut emissions to 1.5 milligram per cubic meters, this is the revolution. We know how strong Germany is in Europe, globally also, and I believe this will overrun the industry. This is much stricter requirement than minus 50, which is required by the European Commission, and everything will move to this 1.5 milligrams per cubic meter. We heard the General Secretary, based on their discussions with German colleagues, they are not sure if they can fulfill this requirement, but we will see. Here, we worked a lot on changing outdated technological plants, do a lot on our equipment. We have good times, so we need to improve our technology. Digitalization in every place, every possible place. Like we said in these 2 days, 3 days, people are the key. And with the right people, right professionals of every type, also people who bring the ruler and smooth out the asphalt surface. Also they are experts, and we have to work with them, also in ZAS. Therefore, in ZAS, we will definitely have new heads of professional boards, we have new committees, and we will intensify our work. In spring, we will organize our training, we will prepare our professional conference at the time of our spring General Assembly meeting. I hope we will manage to do it live, otherwise we will be online. And in the autumn, we are planning the 4th workshop on dimensions in Portorož, as planned. Let me thank you all at the end. First, to our sponsors. They are all presented here. We have very strong sponsors. More and more, we are getting new ones. Thank you. We have high cost of this colloquium. You see that we are not saving on at any point, but we can do it due to our sponsors' support as well. So thank you. Then individual participants, I thank you all in general, but there are some individuals I want to pay special thank you. My team, I got a lot of recognition at this colloquium, but this recognition goes to Tadeja Horvan, Marjan Marolt, Robi Mihelčić, Boris Muškon, Branka Čulić, representatives of Petrol, Borut Gostić and Damjan Sinigoj, and my colleagues when I asked them to bring something from DARS or bring somewhere, Nika Matul and Nika Matul. Since this colloquium had a number of surprises, we still have some of them. Since you remained in such a high number, almost 90 of you stayed with us. Let me show you what our teachers or what our speakers received. All paper presenters and moderators received these frames so that because after the colloquium they will receive a photo to be added into this frame and they can hang it on the wall. This is one thing. This year, we are celebrating the 25th anniversary. We prepared gifts, which we distributed, and I would like to know how many of you were in Mačkovci, Prekmurje, when we celebrated the 25th anniversary. How many of you were present there? So, after we finish, you don't go to Tadej. So, the gifts should first be given to those coming from outside Slovenia, then the young participants, and then the remaining ones, because we don't have enough gifts for everybody. I would also like us to take a photo, all of us here at the front. When we finish, there is coffee and some sweets available before you go, before you leave, and it's just before the Christmas and New Year holidays. I wish you a very nice December. Merry Christmas, relaxing season. And in this crisis, we can see that the figures of the cases of infection are now slowly dropping. And in 2022, I wish that this epidemic is gone and that we get back to normal. Safe journey back, and this is the closure of this colloquium.
Slika bo pa z maskami, ne? Tako da ne bomo...